Good evening. We'll continue. Childhood problems continue. Today, we'll continue the problems of childhood. First, in the beginning, we'll take one or two examples which are familiar. Then we'll go for the next one. Y is equal to log of secant x plus tan x. Now, it's very clear. We need to use chain rule because trigonometric and logarithm functions are interlinked. So we have to first break the chain. How to break the chain? So let y is equal to log u and u is equal to secant x plus tan x. Let y equals log u and u is equal to secant x plus tan x. As I said earlier in yesterday's class, you can recheck whether what you have written is right. How to do that? U is secant x plus tan x. Bring that u put in this place. You are going to get that the problem. That means there is no mistake. What we have written is right. So find dy by dt. It is 1 over u because you can recall that y is log x, dy by dx is 1 by x. So instead of x you have got u, therefore you are writing 1 by u. But what is that 1 by u is equal to? What is u? U is secant x plus tan x. Now we have to differentiate du. So what is du by dx? You have the table with you. Differentiation of or derivative of secant x is secant x tan x. Derivative of secant x is secant x plus tan x. Sorry, secant x into tan x. Plus sign is there, right? And the derivative of tan x is secant square x. So what you can do is you can do some simplification here. You can take secant x common. You get tan x plus secant x. So dy by dx is equal to 1 over secant x plus tan x. This is dy by du multiplied by du by dx, that is secant x into tan x plus secant x. These two will get cancelled. We get the answer as secant x. Let's move on to the next problem. Y is equal to sine inverse of cos x. So how do we work this problem? So let us put y is equal to sine inverse u. Y is equal to sine inverse u and u will be equal to cos x. So put or let put y is equal to sine inverse u and u will be cos x. So first find dy by du. You know that when y is sine inverse x, you can refer to the list of formulas. Dy by dx is 1 over root of 1 minus x square. When y is sin minus x, dy by dx, you can refer to the list of formulas we have listed already. So what is the difference here? Instead of x, you have got u. So you can write this as 1 over root of 1 minus what is u square? U is cos x, 1 minus cos square x. You know 1 minus cos square x is sin square x, and root of sin square x is sin x. Now, you have to find du by dx. Is minus sin x. So what do you want? Now we want dy by dx. You need not write the formula every time. And remember, dy by dx is dy by du into du by dx. So dy by du is 1 over sin x. And du by dx is minus sin x. So what is the answer? Answer is minus 1. In fact, we can also explain this by using trigonometry. That will be helpful for CET. You can write sin inverse as it is. Write cos x as sin of pi by 2 minus x. Just giving this an example. So how the problems are interconnected. So you know that in trigonometry, sin inverse of sin theta is theta. Of course, range is given and lies between minus pi by 1 plus pi by 2. So this is going to be pi by 2 minus x. You differentiate this. The different derivative of pi by 2 is 0 minus 1. So if you are good in trigonometry, some of the problems of, not all, some of the problems of differentiation can be solved easily. And those things are required for CET. In fact, one or two messages were there from the students. Sir, are you going to do CET? Yeah, most probably I may do CET also after the examination. There also I will be solving the KCET papers. Anyway, let us see first. Let me complete what is in my hand. Okay. Let's continue. Let's go to the next problem. Now I'll straight move on to. Yesterday we had case 2 involving two variables u and v. So I'll move on to the sine of log of secant x. How will we know that this is a problem of second category, or this requires two variables like u and v? We can just, once you start working, get an idea. First, we write y is equal to sine u. So u should be log secant x. But log secant x cannot be differentiated without, because beginning a chain. Therefore, we break it. U is equal to log v, and v is. The time I told you, till you are very confident, and always check back. So take this v, put it here, you get log secant x, put that in that place of u, you get back the problem. Therefore, the way what we have written is right. So first we have to find dy by du is cos u. We have to find du by dv. It is 1 over v. So what I can do is, what is cos u? U is log v, that is cos log secant x. I told you yesterday, once you complete differentiation, whatever we have used, you have used u only, replace the values of that. So what is this 1 over secant x? So if you want, you can write this as cos x also. The 1 over secant x is cos x. Find dv by dx. Or better you keep it as secant x itself because it will help us for simplification. dv by dx is secant x into tan x. Now we have to write the formula. What's the formula? dy by dx is equal to, for 1 or 2 problems I am writing the formula. Only for in the beginning we shall write the formula. Afterwards we can work the problem keeping the formula in our mind. So dy by du by dx, so du by dv by dx. dy by du is cos log secant x. Du by dv is 1 over secant x. And dv by dx is secant x tan x. So though I had written 1 over secant x as cos x, afterwards I thought, let us keep it like this. Why? We can cancel this. Let me go to one more problem involving two variables. Y is equal to cos of cosecant of e to the power x. Cos of cosecant of e to the power x. Very clear. It's a problem of chain rule. With your experience of solving so many problems, you have an idea. So how do we break this? We write y is equal to cos u. U is equal to cosecant v. Why should I write cosecant v? Because if I write cosecant e power x, I will not be able to get the solution. Therefore, v is, and v is equal to e power x. So find dy by du and minus sin mu. What's the value of, what is u? U is cosecant v, and is cosecant e power x. So after complete differentiation, we place the value. Now, what is du by dv? Minus cosecant v cot v. That is minus cosecant e power x cot e power x. Then find dv by dx is just e power x. Now, without writing formula, see one mistake has happened. This is dy by du, not dy by dx, because the variable is u. First find out dy by du by final dv by dx. But final answer we want is dy by dx. What's the formula? dy by du into du by dv into dv by dx. So let us write that. dy by du is minus sin cosecant of e power x. And this also minus, therefore I can make this plus because it's a minus sign here. So cosecant of e power x into cot e power x into e power x. Now I want to teach you how to work these types of problems directly. What was our first problem that we worked today? Or we shall take a new problem only. sine of log of tan x which will take, for example. We have got a similar problem earlier. Or by writing this as sine u is log v, and v is tan x. But all that is not necessary, not required, if we can follow this. So just imagine you are entering a Ford, or you are entering your house itself. Ford will have many gates, so let us take an example of house. So as soon as we come, there is a gate in, the gate will be there in front of the house. Afterwards, door is there. And door is locked. Door is locked. Then end. So gate, locked door, and you have to push the door and enter. So as soon as we come, we can't enter directly. We have to pass through the first obstacle. Or the first point is gate. So open the gate. So gate is sine. Sine differentiation sign is cos. When I open the gate, I cannot touch the door and entrance. So I have to write that as it is. I push the gate, I enter. The remaining remains as it is, therefore I am writing as it is. So I have cleared the gate. Now I come to the door which is locked. That means I have cleared this, I will come out here. I have to open the door. That is log tan x. It is 1 over tan x. Afterwards, after door is open, push the door and enter inside. That means you have to differentiate tan x. That is secant square x. Repeat once again. Whenever a problem is given, you have to first differentiate which is the beginning. You can call it a hurdle race or something like that. Whichever you see first. When you are differentiating that, the remaining things you can't touch, so keep it as it is. I am differentiating sine. Sine becomes cos. So this I cannot touch. I just said give an example. When I am opening the gate, I cannot touch the door. Because I have first opened the gate. That time the door lock remains as it is. Okay, that is there. I come near the door, open the lock. So this is the door. I open the lock, then I push it inside and enter. So let me work this problem which is on the board by this method, so that you will have a better idea. I want to work this also. Already work, but we shall work by this method, so that you will have an idea. So dy by dx equals, this is the first obstacle, cos. So first you should differentiate cos. The differential of cos is sine. The other things remain as it is. After cos, you enter inside. I got cosecant. So you should differentiate cosecant. What is cosecant differentiation? Minus cosecant e power x you cannot touch. Cot e power x. Then you differentiate e power x, that is e. First differentiate cos, that is minus sine. Rest you should write as it is. When you enter, you see cosecant. Cosecant is cot. Cosecant into cot minus sine. E power x remains as it is. So this is the direct way of working. Yesterday I didn't talk about this, because I just wanted to understand how the things progress. Let me take one more example now. Now here afterwards, I am going to work problems based on this. This is sine of cos of tan of secant x. I am taking a little lengthy problem just to teach you how you can work these kinds of problems directly. Okay, whatever may be the length of the problem, Supposing, as I told you, you are entering a house, instead of entering a house, you are entering a fort. The fort may have many doors also. So you are tackling the first door you are facing. So here, the first thing that I am seeing is sign. So I have to differentiate sign. Difference of sign, I know it is cos. All these things I cannot touch. Therefore, I leave it as it is. So, a differentiate sign. Once this is over, we enter inside. What is that we see? We see cos. So, differentiate cos. Cos is minus sign. The rest remains as it is. Tan of secant x. After that, we have got tan. What is tan? Differentiation of tan is secant square, but the secant x remains as it is. This is multiplication because there is no space I am writing here. Secant x is secant x tan x. Repeat once again. First, I differentiate sign. I get cos. Rest remains as it is. Then I differentiate cos. Different sign cos minus sign. Rest remains as it is. Then I should differentiate tan. Tan is secant square x. The rest remains as it is. Secant x remains as it is. Then you should differentiate secant x. Let me take one more similar problem. Log of secant of tan of log of secant of tan of cos x. Log of secant of tan of cos x. What's the method? So we should get the solution just in one line. Earlier we thought of log u, log b and all that. Now all that is not required. So differentiation of log is 1 over. So 1 over secant of tan of. That means you are taking entire thing as u in your mind. So log u is 1 over u. Then our secant is something like secant v. What's the difference of secant v? Secant v tan v. So secant, but in place of v, we have got this, we are writing that. Tan of cos x. Secant v tan v. Tan of cos x. Tan of cos x. Then I should differentiate tan. Tan is secant square. Cos x will remain as it is. Then I differentiate cos x, which is minus sin x. The problem is a little lengthy, but method is very easy. First, we differentiate log. It is 1 over. So 1 over whatever is there, we write as it is. After that, we enter. We differentiate secant. Secant is secant x tan x. So the entire thing remains as it is, secant and tan. Then we should differentiate tan. Secant square, the cos x will be as it is. Then differentiate. Cos x will be minus sin x. So let me go to the next problem. I am working 2 or 3 problems of this type so that we get some idea about this. Y is equal to sine square of log of cosecant x. Now here, this is the first obstacle that you should see. Normally students will think that it is sine. No, the power. See, when you come to the house, the door may be in front of you. But if the door has got a lock, so you can consider this too as a lock. So you cannot push the door until you remove the lock. So first you should differentiate power. So you have to recall how the power was differentiated. X to the power of n. That is dy by dx is then x to the power of n minus 1. Or x square is 2x. So you should write first power differentiation. It is 2 sine. You are not touching anything. So you are differentiating power first. So this sign will remain. Then you differentiate sign. What's the differentiation of sign? It is cos. Cos of that you write as it is. Then you differentiate log. You get 1 over cosecant x. Then you differentiate cosecant x. This cosecant x, cot x. If you want, you can cancel this or you can leave it as it, because these are not standard problems. I'm just working them to make the points clear. Let me work one more. Y is equal to tan cube of secant of log of sin x. Tan cube of secant of log of sin x. So, as I explained earlier, the first obstacle you see is the power. It is something like x cube. N x to the power of n minus 1. X cube is 3 x to the power of 3 minus 1. That is 3x square. So, first write this as 3 tan square. The rest is as it is. Repeat once again. The power is there. The entire thing should be considered as u square, rather u cube. So first difference of u cube is, all these you should keep it in your mind. And this requires some practice. Once you pick up this, differentiation becomes easy. This is what I was telling you yesterday. Till we get chain rule, things work out very easy. The real problems start after chain rule. What is solution? Solution is work more problems. The advantage of this is you can watch the video once again, repeat that, try to get the concept. Once the concept is clear, whether you give tan cube or tan to the power, so whatever is given, we can work it out. So the concept should be clearly followed. It requires systematic approach. It requires nothing more than hard work. Okay? So now power is over. I should differentiate tan. Tan is secant square. So I write the rest as it is. Now I should differentiate secant. Secant x is secant x tan x. Differentiate secant x is secant x tan x. Secant x tan x. Now I should differentiate log. This is log sin x. Log is 1 over sin x. Then I should differentiate sin x tan x. So I have just taken 2 or 3 problems just to give an idea. Now I will go for some 1 or 2 standard problems which are in the NCERT textbook and which needs chain rule. They are simple compared to this. They are simple. You may not get a problem like this. I will always make this comment in a classroom. Even after 100 years, UC board will not get this problem. They won't ask this problem. But why do you work this problem? To get an idea. If you want to learn scooter or car, we go to a school ground and learn it. We may not go there and write it again, but we are learning it then. So when we are learning this, I am just giving one step ahead. So the concept should be clearly understood. I repeat, tackle the first obstacle. When you are tackling the first obstacle, the remaining you cannot touch, so keep it as it is. And go in a systematic order, one by one. So the first obstacle you should tackle, that's first thing. The second thing that is important is You need to remember the formulas. There is no other way. Work as many problems as possible until you feel it is very you are comfortable with that. So let me take one or two examples which are in the textbook. And which are comparatively easier than this. The first one, y is equal to log of cosecant x minus cot x. Prove that dy by dx to cosecant x. It's a standard problem. Y is equal to log of cosecant x minus cot x. And whenever the word comes, prove that simplification is a must. If they are not given, prove that differentiate and leave it. No need of going for simplification. Of course, if you do simplification, you are not going to lose the marks. But sometimes, while trying to simplify, you may do a mistake. That's why whenever they simply say differentiate and leave it. Now it is given prove that, so we have got to simplify. So dy by dx. I am working by direct method. This is the first subsequent we are saying. First function we are saying is log. So I should differentiate log. Log x is 1 over x. So I write this as 1 over cosecant x minus cot x. Log x 1 over x, or if you take this as log u, 1 over u. I am not writing u, I am writing this as it is because that I called orally as u. Okay. Now I should differentiate cosecant x first. Of course, that is again addition rule. So we go systematically first term and next term. So what is the difference of cosecant x? It is minus cosecant x cot x. And what is the difference of cot x minus cosecant square x? It is a minus sign. Therefore, it becomes plus cosecant square x. The problem is over. It is not as lengthy as the previous problem because those two problems I just gave you to make the concepts clear for clarity purpose. Normally, we don't get such lengthy problems. These are the standard problems asked in the examination. So we cannot leave it here. We cannot leave this here. Why? They have asked you to prove it. So let me do some simplification. You have got cosecant x cot x and you have got cosecant square x. So you can take cosecant x common. So let us take cosecant x common. When I take cosecant x common, I get minus cot x here. And I am left with cosecant x. If you want, you can check back. Cosecant x into minus cot x is minus cosecant x cot x. Cosecant x into cosecant square x. Always you can do that fast. Cross check. Write the denominator as it is. Cosecant x minus cot x. And wherever these two terms are same, and cancel this, you get cosecant x. Let me go for one more problem of your textbook only. Y is equal to 1 by 2a log of a plus x over a minus x. Prove that dy by dx equals 1 over a square minus x square. It's a standard problem in your NCERT textbook and can be asked in the examination also. See, normally what we do when you work blindly, we see log first, and you are going to write 1 over this. Then this is a quotient 2, they are going to use quotient 2. But this problem can be got in a very simple way. This is not applicable for all types of problems. Wherever log is involved, you need to recall a formula. What is log m by log n? Log m by n is log m minus log n. Yesterday I told you There are many problems, the formulas in mathematics. Which students will complain, oh, there are so many formulas, sir. But they are going to help us. This formula, if you remember, it is going to reduce our work. If you don't use a formula, I'm not going to try that. I don't want to waste time. Again, in the class, I used to do that. I used to work this problem by a longer method, then work this by this method, and make the point very clear for the students. See, if you go like this, how much of time is wasted. Now, the time we have a time constraint. I have only another 21 days left. And I have a lot of work to do, so let us not waste time and directly use the formula. So y is equal to 1 by 2a is a constant. It is something like k into u. The second formula, what did I say? K is a constant. The constant doesn't trouble you. Don't trouble the constant. I repeat, constant will not trouble you. Therefore, don't trouble the constant. Leave the constant wherever it is. It is in numerator, leave it there. It is in denominator, leave it there. So I am leaving 1 by 2a here. I am using this formula log of a plus x minus log of a minus. Now I have to go for differentiation. 1 by 2a is a constant. Now I have to use chain rule. Log u is 1 over u. So 1 over a plus x. Not over, I should differentiate a plus x also. Because I first differentiate out, then enter inside. Differentiate a plus x. Derivative of a is 0, x is 1. So just write 1. For our understanding, even if you don't write, no problem. But we are going to write because next step you realize why we should write. Now we come to this. This is again log of a minus x into minus 1 you get. That's why you should. Here, whether write 1 or not doesn't matter. Here it matters. Therefore, follow the procedure. First, differentiate log 1 over a plus x. Difference of a is 0, x is 1. I write 1 here. Now there is minus sign. I put a minus sign as it is. Log of a minus x is 1 over a minus x. Differentiation of a is 0, x is 1, but minus x is minus 1. So now we need to simplify this. 1 by 2a. 1 over a plus x plus 1 over a minus x. This is very important. You have to be careful when you do the simplification. There is a minus sign. Therefore, minus and the minus becomes plus. Now, what is the LCM? The LCM is a plus x into a minus x. What you get here? You get a minus x here. You get a plus x here. X and x will cancel. You get 1 by 2a. A plus a is 2a over. You can use the formula. The formula we have used number of times. X plus a into x minus a is x square minus a square. So here a plus x and a minus x is a square minus x square. These two will cancel. You get 1 over a square. I'll work one more similar problem. Identical problems. The main reason is when you work two identical problems, the concept becomes more clear. I repeat what I said yesterday. After the class gets over, we find time before you come to the next class, work some problems in your book. If you don't get any other problems, you just copy the problems that I worked in the class and work them again without looking at the notes, and afterwards you can compare. If you do that much, you are prepared for the next class. Things go on easily. So let's go to the next problem. Almost identical, slightly, only to make you understand how the problem progresses. Y is equal to 1 by 2a is as it is there. Log is also there. That was a plus x. Now this is x minus a or x plus a. Prove that dy by dx equals 1 over x square minus a square. That was a square minus x square. This is x square minus a square. Yesterday I told you, I'm taking little more time writing the problem, explaining, because I'm keeping in my mind those students who have got basic difficulties. For them, the basics are not clear. That is not the case with majority. So what you can do is you can complete the problem before I work it out. That will help you in recalling. Okay. Now first step is we have to use the formula 1 by 2a. Log of m by n is log m minus log n. Log x minus a minus log x plus a. We have not done any differentiation. We are using the formula. Yesterday I made a statement. Simplification before differentiation always better. So this is simplification method using a formula. Dy by dx equals 1 by 2a into differentiate log. It is 1 over x minus a. Now differentiate x, it is 1. A it is 0. So into 1 only. Minus differentiate log 1 over x plus a. X is 1, a is 0. Not much of a difference here because both are plus 1. So now what you can do is you need to take the LCM. LCM is x minus a into x plus a. So this is x plus a. This is a minus. Therefore, put a bracket. I always tell the student wherever minus n is there, put a bracket. Use helmet to safeguard that. If you don't write this minus n, terms will not get cancelled, or everything will cancel and get 0 also. So that you have to be careful. Wherever here I have written, even if I write a bracket or not, it doesn't matter. Here I need to write the minus n. So let us simplify this. 1 by 2 is outside. This you can multiply using the formula. You get x square minus a square. So here what happens is x plus a minus x plus a. X and x will cancel. So you get 1 by 2a. A plus a is 2a by x square minus a square. 2a to a cancels. X square minus a square. I work one more problem which is asked in the examination. It was a little more compared to this, maybe a little more complicated. But having gained some experience working these problems, that should be easy for you. If it is not that easy, you have to practice. But that is required. If y is equal to log of x plus root of x square minus a square, prove that dy by dx equals 1 over root of x square minus a square. We are observing the problem standard is increasing. So as we progress, you need to remember the previous concept, then only this becomes easier for us. Well, again it is given us through that we need to simplify. For the information of those students who are in the border case, as I said earlier, scared of mathematics, even if you don't simplify, no matter, differentiation can always be done. It is possible. Because you know differentiation. First thing is, you have to write dy by dx. So log is 1 over. So write 1 over x plus root of x square minus x. Then you need to differentiate x. X is 1. That is not difficult. Here, the first obstacle is root. So first you have to remove the root, then only enter inside. Open the lock and then enter inside like that. So first you have to remove the root. It is something like root u. So what is the differentiation of root x? You have to recall. Y is root x. Dy by dx is 1 over root x. If you have got u, you will write 1 over u. But you have got root of alpha, root of x square minus a square. So I write this as 2 into root of x square minus a square. Now I should differentiate x square. That is 2x. I should differentiate a square. That is 0. So let me use the bracket. So this is 1 over u. X is 1. Root is 1 over 2 root. If I enter inside, x square is 2x minus a square. Now here you can cancel q1. As I said earlier, compared to the previous problem, this standard is more. The standard is go on increasing. So this is equal to 1 over, write this as it is. Now you need to take a LCM. Of course, what is the denominator? You should take it as 1. So LCM is x square minus a square. So what do you get? X square minus a square plus x. These two are same. Can cancel this. So what you get is 1 over root of x square. So there is one more problem of this type. Instead of x square minus a square, they will give you a square minus x square. The answer is going to be 1 over root of a square minus x square. That I am not going to do. I am just telling you, if you want to have better ideas, work that problem. I repeat, the problem is same. Log of x. Instead of x square, you have got a square here. It is a square minus x square. The answer is going to be 1 over root of a square minus x square. But I am working one more problem which is little more standard than this. Because if you can work those problems, then you can tackle any problem in differentiation. So let me work that problem. Compared to this, the standard of that is going to be little more. If y is equal to x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a. Little more standard. Not that difficult. Only thing is you need to understand the basic concepts. So y is equal to, you can notice one thing here. Here also 1 by 2 is here also 1 by 2 is there. So let us first simplify by taking the constant outside. You can safely place the constant outside. So this is x into root of a square minus x square plus a square into sine inverse x square. I have just kept it constant outside. Now I need to differentiate. This is 1 by 2 as it is. Now what is that you see here? It's a product rule. X is one function, root of a square minus x square is another function. You need to use product rule. At the same time, difference of x is easy one, but a square minus x square you need chain rule. So that is where we have difficulties. First of all, it's a chain rule problem. Here again, it's a product rule. Of course, when you got a plus sign here, it is addition rule. What are the addition rules tells us? Differentiate the first one, then go for the next one. Here is a product. So I should recall that. What's the product rule? Excuse me for one function, differentiate the next one. So I should say excuse me for a square minus x square and differentiate x, I get 1. Plus, I should say excuse me for x, differentiate root of a square minus x square, which is the first obstacle root. What is the derivative root? 1 over 2 root a square minus x square. First you differentiate root, then enter inside. A square is a constant, it is 0. There is a minus sign. X square is 2x. So write minus 2x. The problem is not over. We have different only the first function. Now here you see it is not a product. Why it is not a product? Of course it's product, but product rule is not required because a square is a constant. Whereas here both are functions. Therefore what you can do is keep a square as it is. Differentiate this. What is sin inverse x by a? If you can recall, I have listed that in the formula 1 over root of a square minus x square. If you can recall. Supposing you are finding difficulty, I can just explain how it has to be done. You have got sin inverse x by a. So I call this as y is equal to sin inverse u. What is my u? X by a. So this is a strategy. Whenever you find difficulty, go back. So I am explaining this. So what is sin u? It is cos u. What is u? U is x by a. Du by dx. Here 1 by a is a constant. Keep it outside. Constant wherever it is, leave it there. Numerator, leave it in none. It is a denominator, leave it. It is a denominator, leave it there only. X is 1. So this is just 1 by a. Sorry. I have a mistake. It is not sin u. It is sin inverse u. Sorry, this mistake is there. It is sin inverse u. Because the problem is sin inverse. So what is sin inverse differentiation? If y is equal to sin inverse x, dy by dx is equal to 1 over root of 1 minus x square. So if you follow that, you get 1 over root of 1 minus u square. So but what is u? U is x by a. 1 minus x square by a square. If you take LCM, this a square will come to numerator, becomes a, and this is a square minus x square. Now what should I do? I have to find dy by dx. I repeat here, I have taken LCM. This a square in denominator, it is inside the root, it becomes a, it comes to numerator, a over this. So this is a over root of a square minus x square multiplied by 1 by a. So this a and a will cancel, you get this solution. But I would rather advise you can remember sin inverse x by a as a standard problem. We have listed, in fact, you can check back and see the formulas are listed. So let me continue. So dy by dx is also not required. So this is 1 by, so differentiation is over. Especially in second PUC, in differentiation, 1 or 2 steps is differentiation. Whenever a problem is lengthy, rest is differentiation, simplification. Most of us have problems in simplification because, in case, I'm not talking about everybody, in case you are not got algebra properly in high school classes, the problems remains. Otherwise, you can practice it easy. Here it is 2 and 2, you can cancel this. And take the LCM. The LCM is root of a square minus x square. So this will become a square minus x square. This will become x into x minus x square plus a square. You take LCM, you can take this as by 1. A square. Root of a square minus x square into root of a square minus x square. Root will go a square minus x square. X into minus x square plus a square. Simplify this. You get 1 by 2 into. This is 2 into a square minus x square by root of a square minus x square. These 2 will cancel. Okay? Root of a square minus x square. Because I have not given you the problem clearly. Prove that I have not given. It will be given like this. Prove that dy by dx is root of a square. It's all standard problems. In fact, these formulas are more required for integration. When I start integration, I'll be recalling all these things. So keeping that in mind about these problems. So we have done the basic differentiation, problems on addition rule, quotient rule, and chain rule. Is it enough? No, definitely not. You need to work more problems or practice them. Now I will be moving on to the next concept. How I planned is, before I start working the question papers, problems of calculus, especially differentiation, that is continuity and differentiation. I'm just giving you the basic ideas, what are the things that are required. So the chain rule is over. What is the next concept we need to have an idea? That is differentiation of implicit function. Differentiation of implicit functions. See, what I am giving you is something like a trailer of the film. Whatever is there, all concepts I am just showing you, synopsis you can say, a trailer of film you can say. So, repeat, problems of addition rule, quotient rule, chain rule. Now, all these rules are required for the next concept. Implicit functions. What are implicit functions? In a simple term, functions having more than one y term or power on y are called implicit functions. See, this is not the actual definition. I don't want to confuse you by giving the actual definition. I am just putting it in a format where you can understand easily. Any function where you find more than one y term or the power on y, they are called implicit functions. See, whatever problem that we have done for the past 3 days, including today, the function is to start y is equal to sin x, y is equal to log x, something like that. Now, we are having a different problem where you find more than one by term. Simple example, x square plus y square is equal to a square. 2x plus 3y equals sin y. I'm just giving 2 examples. Or x to the power of 2 by 3 plus a to the power of 2, sorry, y to the power of 2 by 3 is equal to a to the power of 2. Such types of problems are called implicit functions. And functions are called implicit functions. How we have to differentiate this? Same procedure, there is no question of changing of rule. For example, if I have got y is equal to sin x, I will find dy by dx is cos x. But if I have got y is equal to sin y, dy by dx is equal to cos y into dy by dx. Here we have just written cos x. Here we are writing one more extra. You should understand why that extra term comes. I'm just explaining in a way that you can follow. A simple way for understanding purpose. See, what is the meaning of dy by dx? Differentiate x with respect to x. So when I got y is equal to sin x, now I have to use, let us use, I know it is cos x, but I will use chain rule for this to make you understand the implicit function. So dy by dx is equal to, I first differentiate sin. Sin becomes cos. I should write x as it is. Now I should differentiate x. What's the difference of x? It is 1. Therefore, I don't write. I simply remember as cos x. One more problem. If I got tan x, I'll first differentiate tan. I get secant square x. Then I differentiate x. It is 1. Let me explain the same thing here. Instead of sin x, I have got sin y. Instead of sin x, I have got sin y. So I will differentiate this with respect to x. I am using chain rule. So I must differentiate sin first. Sin is cos. I should write y as it is. Then I must differentiate y. What's the difference of y? dy by dx. You should understand this. I have written dy by dx. What is the meaning of that? Derivative of y is dy by dx. So here y is dy by dx. What will happen? Dy by dx will cancel? Yeah, definitely. But such problems will not be given. It's only for example. Because y cannot be equal to sin y. I've taken only an example like that. Okay? So here, what will happen? This example, you find dy by dx. Only thing I took this example to explain you that you should differentiate x. You get 1. Therefore, you don't write, and the y is there. Let me explain one more problem you should take. I got x square plus y square is equal to a square. What is the difference of x square? 2x. I don't into difference of x also it is 1. So we don't write because derivative of x with respect to x is 1. So we don't write that. So I just write 2x. What is the difference of y square? It is 2y into what's the difference of y? dy by dx. So if secant y is there, What's the derivative method? Secant y, tan y, dy by dx. This you should remember. Whenever you have got y, after differentiating, you should multiply it by dy by dx. Why? Because you are differentiating with respect to x. Supposing they are given differentiate with respect to y, then there is no need, but they won't give that because all differentiation is done with respect to x. Supposing I have got cosecant y, asked to differentiate, it is minus cosecant y into cot y into dy by. If I have got y to the power of 7, what is the answer? 7 y to the power of 6 into dy by dx. So this one extra thing you need to differentiate. Remember why we are writing dy by dx? Because differentiation is done with respect to x. So let me now work some problems based on this. So I repeat, any function which has got a power on y or more than one y term, it is called implicit function, and the procedure after that. Let me start with the first problem. 3x plus 4y is equal to cos y. The problem that we did so far earlier is to start y is equal to something. Our first step would have been dy by dx. But here you have to go through the problem. It is not a actually that those functions are called explicit functions. Only for information, because I am not explaining the difference and all that. They were called explicit. So when we talk about types of function, we call them the explicit. This is implicit. But for your understanding, I made it very simple. How to identify implicit function? There is a power on y or more than one by term. So you should differentiate 3x first. It is 3 because x is 1. 4 is a constant. What's the difference of y? It is dy by dx. What's the difference of cos y? It is minus sin y dy by dx. You understand this? Not much of a difference. Same procedure, same formula, and everything same. Only extra thing is you have to remember you are differentiating with respect to x. Therefore, this extra term will come. I cannot leave the answer like this because finally we should get what is dy by dx. Because differentiation means find derivative with respect to x. X means you have to find dy by dx. So what we do is we are going to group it. This will take all the dy by dx to one side. So I will take dy by dx. This 4 is there. I bring in minus sin y here. It becomes plus sin 4 plus sin y. And I will send this 3 to other side. Now I want dy by dx is minus 3 over 4 plus sin. So you need to remember two things here. First thing is when you are differentiating a cos x, it is minus sin x. When you are differentiating cos y, it is not just minus sin y. That should be multiplied by d. I'm just giving an example. Multiplied by dy by dx. That means you have to just differentiate. After differentiation, you cannot leave the answer like this. Finally, you should get what is dy by dx. It's a part of simplification. Let's go to the next problem. X cube plus y cube is equal to 8. How do you know it's implicit? Because the power on y. So this is 3x squared. This is 3y squared, not only that, into dy by dx. A cube is a constant, don't write 3a squared, it is 0. So 3y squared dy by dx is equal to minus 3x squared. 3 and 3 will cancel. So dy by dx is equal to minus x square by y square. We go to the next problem. Sin y plus cos x is equal to 7x. I'm just take very simple problem beginning. Later, maybe today I may not be able to complete it implicit. Whatever possible I will, I'll just work some more problems in case the time doesn't permit. After implicit function, we'll have to go for the next second category. What is difference of sin y? It is cos y. Not enough cos y into dy by dx. Differentiation of cos x is minus sin x. If you want, you can write minus sin x dx by dx, that will cancel. No need of writing that. 7x is 7. The problem is not over. You have to find dy by dx. It is 7 plus sin x divided by cos y. After differentiation, you have to simplify and write the answer for dy by dx. Let's go to the next problem. xy is equal to 5. When a problem like this is given, I have seen in the classroom, many students will make a fundamental mistake. What is that? Where x is 1 and y is dy by dx, 5 is 0. The normal mistake done by a student. But you should remember, it's a product. So you cannot do it like that. You need to use product rule. What is product rule? We'll excuse for y, differentiate x, I get 1. I excuse for x, differentiate y, I get dy by dx. And 5 is 0. So x dy by dx is equal to minus y. So dy by dx is equal to minus of x plus y. Sorry, we go denominator. Minus y by x. Because x is multiplied. So let me go for the next problem. X square plus xy plus y square is equal to 5. So same procedure. Difference of x square is 2x. But xy should remember it's a product. So you need to use product rule. So keep y as it is. X is 1. Keep x as it is. Y is not 1, it is dy by dx. So you need to use product rule, excuse the rule, excuse for y, x is 1, excuse for x, y is dy by dx. Plus, what is y square differentiation? 2y dy by dx. 5 is a constant. You cannot leave the problem here, you need to simplify. So let us list those terms which has got dy by dx. Here you have got x plus 2y. Other terms can be sent to the right hand side. Minus 2x plus y. What is your final answer? Dy by dx is equal to minus of 2x plus y divided by x plus 2y. I'll take one more problem, not one more. Let us work whatever possible till 8:30 we'll do it. 4x square plus 3y square plus 7x plus 8y plus 5. Purposely I have taken a little lengthy problem. But once you know how to work How many terms are there? Doesn't matter. Because you remember we are tackling only one term at a time. We are not working and tackling all the terms at a time. So the first term I have to differentiate, next term I have to differentiate, next term I have to differentiate. Based on the procedures. So when I'm differentiating a term, you should remember what is the term, how to differentiate that. I need to remember the rule also, the tool also. Now I differentiate 4x square. 4 is a constant, x square is 2x. So with our experience, we can write this directly in x. How we used to do earlier? 4 bracket x square is 2, x to the power of all the is not required now because we have gained some experience. Plus 3 is a constant, y square is 2y, 6y dy by dx. 3 is a constant, y square is not just 2y, it is 2y dy by dx. 7 is a constant, x is 1, therefore it is just 7. 8 is a constant, derivative y is dy by dx. 5 is a constant, it is 0. Now let us group the terms containing dy by dx. 6x plus 8 into dy by dx is equal to minus of 8x plus 7. So what is the final answer? Dy by dx is equal to minus of 8x plus 7 divided by, this is not just 8, it is 8x. 6y plus 8x. So 6y, this is 1 minute. 8x plus 7. Yeah, it goes on the side. And this is on this 8 only, no x is there. Right, correct. Because 6y plus 8. So 6y plus 8. Repeat, you are grouping 6y plus 8 only. And now I am sending this 8x outside because both are empty of the minus sign. Let's go for one more problem. 4x square plus 3xy plus 5y square is equal to 0. Now, x square is 2x, therefore 8x. 3xy, 3 is a constant, keep it outside. xy is a product. Don't differentiate x as 1 and y as, no, you got to use product rule. So excuse me for y, differentiate x. Excuse me for x, differentiate y, you get dy by dx. I repeat, xy is a product. Therefore, you need to use product rule. Plus 5 is a constant. Differentiation of 5 is 0, but 5 is multiplied by y square. So keep 5 as it is. Differentiate y square, you get 2y. Therefore, this is 10y dy by dx. That is equal to 0. Let us group it. 8x plus 3y plus 3x dy by dx plus 10y. I'm doing simplification. Normally, in most of the problems, the problem gets over in first step. Most of the problems. Differentiation is very easy. But why do we complain? Because we are finding simplification difficult. What's the reason for that? You know the reason. You would not have studied algebra properly in high school classes. I'm not talking to everybody. Those who complain that it is a very lengthy and simplification, confusing, all that. It is not because of second period. The problem lies there. So I always tell the students, please pass on message to your youngsters. They are in second PUC and are finding this difficult. A friend of you or a brother of you or somebody studying in 8th and 9th standard, tell them, well, see, I didn't study the algebra properly in 8th and 9th standard or 10th standard. I'm finding second PUC difficult. See, passing is a different thing. Getting 30 marks, these days passing an examination has become very easy. And getting a seat for any percent is also very easy. Because there are so many institutions, they want admissions. So they are not looking at percentage. So when you don't get more than 80%, it means there is some problem with you in the basics. But somehow even without it also, you can get on, you can complete a second PUC. That's a different story. But what I want to convey to you is at least pass this information to your friends or brothers or sisters in 8th and 9th. Tell them, study everything properly. Give importance for simplification. So we are not learning for the examination, we are learning for life. That message should go. It's not that everybody will be alert. At least another 10%, another 10-15% will definitely take a little more care. That is how we can reduce the number of failures. dy by dx is 3x plus 10y. This is minus of 8x plus 3y. Therefore, dy by dx is equal to minus of 8x plus 3y divided by 3x plus 3. I give one more problem of the same type. 5x square or 5x cube plus 6xy plus 3x square y. I'm making it a little more complicated. But remember, you are differentiating only one term at a time. Plus y cube plus 6x plus 7y is equal to 9. Chances of getting these types of problems in examination is very rare. But why do I give this problem? Because when you work a problem which is little above the standard, and if you can digest that problem, the other problems becomes easy for you. That's the reason we hate that. Okay, let me work this. I think this is our last problem in today's class. Or if time permits, we'll work one more, depends on time. Now to close by 8:30. So 5 is a constant, x cube is 3x square, x cube is 3x square, therefore it is 15x square. What is that you notice? You got xy there, product. So you need to use the product rule. So x is 6 is a constant, keep it outside. X cubes for y, differentiate x cubes for x, differentiate y. When you are differentiating this, don't worry about the next step. This is what you should done. Concentrate on what term we are differentiating. I always tell the student, give the devil its share. So you are working on this. You concentrate on this, forget about the rest. Now this is over, I leave it. I come to this. What do I notice? It's again a product. So I'll first keep 3 outside. Now it's a product. So I excuse me for y. I differentiate x square, I get 2x. Excuse me for x square. I differentiate y, I get dy by dx. Plus 3y square is y cube is 3y square dy by x. 6x is 6 because x is 1. 7 is 7 dy by dx. That is equal to. I repeat this. I keep 5 as it is. X cube is 3x square. It is 15x square. I notice that it's a product with KU also. So let us keep constant outside. Let us use product rule. Excuse me for y, differentiate x. Excuse me for x and differentiate y. Again, we notice it's also a product. So keep 3 outside, of course, constant outside. You keep y as it is, or excuse me for y, differentiate x square, and excuse me for x and differentiate y. Just here it is x square, therefore 2x, then it is y divided by dx. Then I come here, this is 3y square divided by dx, x is 1, therefore it is 6, and 7 is a constant, y is dy by dx. The problem is not over. We have to group the terms contained in dy by dx. Which are the terms contained in dy by dx? No, first let us simplify that and then group it. So we have got 15x square plus 6y plus 6x dy by dx plus 6xy. 2 into y is 2x into x 2xy into 3 6xy plus 3x square dy by dx plus 3y square dy by dx plus 6 plus 7 dy by dx is equal to 0. Whenever there are more terms, there is a possibility of missing one of the term. Therefore, what is the cross check? Count the number of terms. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I am talking to the students who are missing a mark, getting 19, 99. These are the areas where you have to be cautious. Sometimes oversight we miss one term. Okay, now what is the next thing? You just group the terms contained in dy by dx. I'll give an easy method. You just write this, put a bracket and equals it. You look at the term. If this term is not multiplied by dy by dx, put a minus sign and send it to denominator. Sorry. Send it to the numerator. 15x square. Let me use the direct method by another. So what you can do is you write dy by dx, put a bracket. Now, if the term is not multiplied by dy by dx, send it to numerator. This is not multiplied, send it to numerator. This is multiplied, send it to denominator. This is not multiplied, send it to numerator. This is multiplied, send it to denominator. This is again multiplied, you go to denominator. This is not multiplied, this is multiplied. I am giving a easy method. I repeat, write dy by dx, should put a minus sign because the terms when they get shifted other side, you get a negative sign. Put a minus sign, put a bracket. If the term is not multiplied by dy by dx, it goes to numerator. If the term is multiplied by dy by dx, it goes to denominator. You can, if you want, you can try this again at home by multiplying and grouping and finally get this answer. So with this, let me close today's class. Tomorrow, I have got some more standard problems of implicit functions again. That I am going to work tomorrow. Then there are some special problems. After that, we'll go for the next one, parametric, logarithmic, all these problems. So I'll be just giving overall idea of what are the contents of the differentiation. Thank you. Good night. We'll meet tomorrow, 7 o'clock.